Today we're going to add our motion control option to our Compact Logix PLC. On our trainers, we use Yamaha's linear actuator, which integrates really easily with a Compact Logix or Control Logix PLC. And this is probably something we don't stress enough is this is a non-motion PLC. So to do typical motion in a kinetics, you would need a 1769 L18ERM BB1B. But with the Yamaha option, we can use a non-motion PLC, such as your trainers, which is a 1769 L16ER BB1B. And before we even get into Studio 5000, there are two files that we want to download. Let's start by going to yrginc.com. And you are going to need to create a login in order to get to My YRG. Now, it is free to create a login, but you must have purchased a linear actuator or a robot from YRG to get access. And we do pass that information on when you purchase our trainer, so you will have access to this. And what you do, we're going to go to the software section. There are two files here that we want to download. First, we have the TS Manager software. That's for actually going in and configuring your motion controller. We're not going to use it in this video, but it'll be a good one to have for later. And if you look down in this chapter, we have a video on installing it. And then a little further down, we have the Allen Bradley YRG Yamaha single AOI for the TS series controller. We want to download that file. And I said two, but actually let's go and grab one more file that's going to be really helpful to you. Let's go to twcontrols.com/getting started. This is where the QR code on the front of your trainer actually takes you to. And there are the videos there for unpacking your trainer, a little about getting familiar with it. And then we have the drawings and sample programs. Let's go into the sample PLC programs that are pre-installed on your trainer, and let's download the Studio 5000 program for the Compact Logix PLC. And if we extract the Yamaha AOI, then we are going to get the LK5 files that we're actually going to import into Studio 5000. And there is a PDF guide here that's going to walk you through exactly how to install this and get it up and running in your Compact or Control Logix PLC. So this is pretty much what I'm going to talk you through. But first, let's have a look in the Getting Started program that we downloaded off of twcontrols.com, because it has a lot of the end result. That way you can have something that you can easily look at and compare back and forth if you have any problems. It already has the module added under Ethernet inside of our IO configuration. And if we open up our main program, then under the LMC option, it already has the add-on instruction. And that's the two things we're really going to talk through today. So let's go ahead in a new copy of Studio 5000 and click File, New. And you have a 1769 L16ER BB1B. And I am going to call this my LMC. Now you can use any version with this add-on instruction, but I'm actually going to do this on version 36 because there is one little hitch that I just want to make you aware of. Your trainer comes with 0 modules, but I actually have 2 modules on this trainer. So I'm going to select 2 modules and click Finish. And the first thing our guide's talking us through is adding this new module. And this is what we're going to do in a second. And the main thing I want us to focus on is a few differences on this screen right here compared to what's in the manual. So let's go ahead and right-click Ethernet underneath our IO configuration, new module. And in the filter box, let's start typing generic. And you're going to see 3 options left. And we want the generic module. Highlight it. And we want the generic Ethernet module. Highlight it and hit create. And then I'm going to name this linear actuator. And this is the important piece right here, this COM format, because this is the one thing that you cannot change later. And so if we look over here in the installation guide, it says it says a COM format of int, which stands for integer. We must select that part right there. Now the IP address is different than what is shown in the guide. And if we actually look in our getting started program and go down to that module, let's right click it and go to properties. Then your default IP address on your trainer is going to be 192.168.113. Now on my video trainer, it is actually 192.168.194, but put yours in as 13. And then we need to set our assembly instance. The input, output, and configuration will be 100, 150, and 1. And there is no magical rhyme or reason to these numbers. Every manufacturer, you're going to need to go find those. So I'll enter 100, 150, and 1. And then our sizes are 6, 6, and 0. So we'll enter 6, 6, and 0. And we'll go ahead and click OK. And all the defaults will be fine for this. Simply click OK. And if I was doing this normally, I would go ahead and continue on. But let's go ahead and download this program. That way we can see what issue we would have if we did anything wrong in that little bit there. We got communications, who active, and the default IP address of your PLC trainer is 192.168.110. Then download it. If you need any help downloading your program or setting up your drivers, then look down in the description. There is a course there that walks you through each one of these steps. And if you haven't already, you should go ahead and hit that subscribe button because we put out at least one how-to every week. I'm going to click yes to put it back in run mode. And the big thing that I want to see here is that I have a solid I/O light and it says I/O OK. So I'm going to unplug the Ethernet on my drive. And now it says I/O not responding. So if you see I/O not responding here, then you want to go down into your I/O configuration and find the microscopic little yellow triangle. That's where your problem is. And we're going to right click it and go to properties. And then we want to go look at the connection tab. And down here it says connection request error, connection request timed out. That means it can't find the module out on Ethernet. And that will likely be that we have the wrong IP address entered right here. The other thing that it sometimes says here is that the size is wrong or the location is invalid. If you see either of those, then it's going to be this assembly instance or size over here. We look okay, so we're going to continue on. So we're going to go communications, go offline. And when we create this, we actually end up creating controller tags up here too. So if we open up the controller tag, we now have linear actuator :C, linear actuator :I, and linear actuator :O. That is configuration, input, and output. And if we open up these, we'll notice that they're completely empty as far as what any of this stuff is. And Yamaha has made it really easy to get our descriptions in. So if we go right past what we just did, and it's opening them up, and yeah, we're seeing blanks as they are. But now we can import our comments. Now we need to make a modification on the way here because theirs by default is called the TSS. That's the name of the module. We named ours linear_actuator. So we're going to open up this Excel file that has the tag import in it. And that is right here. And go ahead and import it into your spreadsheet editor. And we're just going to do a find and replace. And so I'm going to find TSS and I'm going to replace it with linear_actuator. And we'll just replace all. Then I'll close that. And then I'm going to do a file, save as. And I'm going to save this in my downloads as linear import. And we're going to save it as a CSV format. And now if we go over to Studio 5000, we can go to Tools, Import, Tags, and Logic Comments. And I will select the linear import that we just did and hit import on it. And the moment I do, now I've got descriptions over here. So that'll get those in. And next we're ready to add our add-on instruction. So add-on instructions have two main purposes. First of all, integrating third-party devices. You'll almost always go to that third-party manufacturer's website and download the add-on instruction. And the other one is to make code uniform. And we're probably going to do some videos on that soon. Let's right-click our add-on instruction and import add-on instructions. And then we'll go into that extractive folder and we want to get the YAM TS AOI. We'll click OK. And this is the part that I wanted to warn you about with version 36. Notice as it's importing it, it has 186 warnings, which is terrifying. This has to do with a change they made in version 36 to some instructions, and we have a video talking about it. Then mainly it was some renaming of compare instructions, move instructions. This is going to work perfectly fine. So we'll click OK to that. And while we're at it, let me show you another neat way that you can do add-on instructions. And actually, I'm going to hit cancel on that. And since we already have it over here in the Getting Started program, we can also right-click and copy add-on instruction. And then go over to this folder and right-click, and we can paste it. It's going to paste in, and notice this ramp it up. We still got we only got 165 errors that time. I don't know why there was a difference in the errors, but it's going to work the exact same way. Okay, so now we're ready to write some program. So let's go ahead and open up our main program, and then open up our main routine. And you know, we're usually hitting our favorites, we're hitting our timer counter and all that, but the category to the right of our favorites is actually add-on. And we have a YAM TS AOI instruction now. So let's drag that down. Now, initially this can look really intimidating, but this is incredibly easy to set up because it's a single block to do everything. And if we actually go over to our motion categories, first of all, how many motion categories do we even have up here? We got a boatload of them. But so to do the equivalent in kinetics, we got to go through and learn all of these things. Which don't worry, we're going to still learn all those things, but we're going to get this set up first. So let's start off by just giving these tags names. So I'm going to call this my linear AOI. And after we type those words, we're going to right-click them, new, and create. So next we have our config, and I'm just going to call it my linear config, and we'll right-click, new, create. All right, now the map robot inputs and map robot outputs, those tags actually already exist. They came in when we created this. So we're going to double click there, and we're going to follow our arrows and get linear actuator : I data. And then for the outputs, we'll follow our arrows and get linear actuator : O data. Serial number, I'm just going to call it linear serial. So for the rest of them, let's go ahead and just type all of these in. Don't even worry about creating them. I'll create them with you at the end. Now that they're all typed in, we're going to right-click each one of them, new, and it's already going to know the data type that we need based on this AOI. So just hit create. And we'll just right-click all the way down through these. This one needed to be a bool. And just keep going through all of them. And when we create the last one, we should see this red X go away. And we do, and that's how we know that we created all of them. If your red X doesn't go away, then chances are look down through here and you're going to have a question mark still in here. All right, now we want to address each one of these so we can talk them out. And if you go through Yamaha's guide, they're actually talking through each one of these very thoroughly, and that's what we're going to do. So let's take these one at a time. So first of all, we have our serial number, and we just need to enter that one. So let's right-click it and monitor serial number. And then we want to hit the dialog box. You can find your serial number on the side of your linear actuator, and it's also on the side of your TS controller. So in the case of this one, it is the part after SH dash. So all you enter is YRG and then that serial number. Next, we have the EN phaser. And this has to do with the precision of the linear actuator. And YRG does a really good job of putting a description of each one of these, but we need a 0 in there. Now, here's something I'm going to caution you of is, since it is a 0, I could simply just leave it like it is, but we're going to throw some ones in here also. And I kind of like to have them out where we can figure out why they are what they are clearly. So to put a 0 here, the data type is a bool. So I'm going to go to my favorites and bring down an output energize and bring that EN phaser up. And in front of it, I am going to bring down a go look for a 1. And then actually I'm going to highlight the shape and just type AFI and press enter. This is an always false input. And when an output energize is false, it is going to go right at 0. So that is the same as leaving this blank. So next we have the mode select, and we want to use a mode select of 1. That way we can use the move absolute position and do our positioning and speed inside of our compact logics. If we have it as 0, then it'll move based on the points. So I want to go, and first we're going to mouse over that. Notice it is an integer. So I can't use my output energize. I'm going to use a move instruction. So we'll bring a new rung down, and let's go to the move logical tab. And I'm going to bring an MOVE instruction down. Now, if you're doing it before version 36, this is an MOV instruction. So it's just some massaging that Rockwell did to the instruction names. But I'm going to 1, and we're going to put that into our mode select. And I don't want to use the points table in this video, so I'm just going to put nothing in front of it, and that's always going to put a 1 into it. The next one we have is the safety interlock, and I'm going to need a 1 in it, so I'm just going to bring another rung down and go back to my favorites tab, and we'll bring down an output energize, and we're going to grab that safety interlock. Okay, servo on. Now, I don't actually know how we want to turn this servo on and off yet, so we're going to bring a rung down for it. And I'm going to show you the easy way to just bring a toggle out, but still have it in a program where we're going to know, oh yeah, that's something we have to deal with. So we're going to bring an output energize down, and in front of it, we're going to put a go look for a 1 in, and we are actually going to make the servo on both the go look for a 1 and the output energize, because now I can right click and I can toggle here. It'll stay a 1. Right click, toggle here. It'll turn it back off. And on power up, it will also set it to 0. Now we'll probably eventually add this to a switch or something in this video, or we may just leave it like this. Okay, now we do need to origin our actuator. So I'm going to bring down a rung for it. And we'll bring a go look for a 1 down and output energize. And we will put that origin and output energize. And we're going to use the blue button to home our system. No, I didn't actually talk about that, but our trainer is wired per the getting started guide, which means button 1 is input 0, button 2 is input 1, button 3 is input 2, button 4 is input 3, and switch 1 is input 4. Now, if you watch some of our earlier videos on the linear actuator, we actually did wire these in, but I wanted to simplify it back down to the getting started guide. So let's go ahead and fill in our descriptions on those. So open up your controller tags, and let's go down to our local :1:i's data. So 0 is going to be our green button. 1 is going to be our yellow button. 2 is going to be our red button. 3 is going to be our blue button. 4 is going to be switch 1. And then let's close that up and let's go to local :1:O data. And output 0 is our green light. Output 1 is our yellow light. Output 2 is our red light. And output 3 is our blue light. Now go back to our main program, and yeah, we want that blue button to be our home. So we're going to go find local :1 :I dot data dot 3. So now we can use the blue light to home it. And then next we have auto mode. All right, I think we want to use switch 1 for auto. That way, if we're to the left, we're going to be in manual, which will let our jog buttons work. And if we're to the right, then it'll work off of these absolute positions down here. So let's bring down another rung, and I go look for a 1 and an output energize. And we are going to grab that auto mode tag and put it into the output energize. And then we want to grab switch 1, which is going to be local :1 :I dot data dot 4. So that'll put us in the auto mode. Okay, now we need to jog forward and jog reverse. And I think we'll use the green and yellow buttons for that. So let's go ahead and bring a couple more rungs down, and I'll go look for a 1 down and output energize. On the second rung, we'll do the exact same thing. And then so it's almost the same thing. We have the blue button right here. One thing you can do to save time is if we actually click the words, the tag words, we can drag that down and get that filled in close. Because then all we need is 0 for our green button. Now, a word of caution to that. When I say the tag words, I mean this piece right here. If I grab the words blue button, that's a description. It's actually part of the instruction. And so I'm going to end up dragging the instruction down. So be really careful when doing that. But that's a real quick way that we can kind of save ourselves some programming time. And so we'll grab 1 for our yellow button. And so, yeah, we'll jog forward with the green button. We'll jog reverse with the yellow button. Next, we have manual step. And it needs to be a 0 for what we're doing right now. And I could just leave it like that. But similarly to the EN phaser up here, I want to know why we're doing what we're doing. So I'm going to bring a new rung down. And we're going to bring down, I go look for a 1. And here's where we just highlighted the shape and typed AFI. That'll turn that into an always false input. And then we'll bring an output energize down and manual step. Okay, now we probably do need a fault reset. So let's go ahead and use the red button for it. So we'll bring a go look for a 1 down. And let's get local :1 :I dot data dot 2. And then we'll bring an output energize down, and we'll grab the reset instruction. All right, now the move OK, we do need a 1 in it. So I'm going to bring a new rung down, and we'll just simply grab an output energize and put move OK in it. That way it'll always have a 1. Now we're not using the move point here, so I am going to skip over it. And then finally we have move absolute position and move speed. And these are the two that we're actually going to operate this off of in auto mode. Now, as of right now, we're not automatically entering any values in. So similarly to what we did with the AFI up here, just so we'd have them, we're going to do the opposite on these. We are actually going to go to our compare tab, and we're going to bring an EQ down. Now, if you are I need to bring a rung down first. Now, if you're using 35 or earlier, this was called an EQU. And starting with 36, though, it is now an EQ instruction. And so I am going to look at our move absolute position to be equal to 0. And then we'll bring another one down, and we're going to look for a move absolute speed to also be equal to 0. And then, similar to we had the AFI here, let me show you another trick you can do is, I don't want to do anything with these. I just wanted them out here where I could see them. So I'm going to bring down a go look for 1, and I'm dragging the go look for 1. You can drag any of them, because also notice you can double click on the shape and you can get the drop down. But as long as you know the code of it, I'm going to type in NOP. and that's a no operation. So all we've done is turn these up here where we can easily see them. Now that should be enough to get us going, but I want to go ahead and use our lights to indicate a few things also. Let's bring a new rung down and let's put a go look for a 1 in. And the first thing I want to know is our servo on? So if we hit our drop down and we're actually going to look into this linear AOI, we can get some really good information right there. So open up the arrow by linear AOI, and down there we're going to see our servo on. And if our servo is on, I'm going to turn on our green light, which is local colon 1 colon O dot data dot 0. Let's bring another rung down and let's look at the position complete bit, because it's one that you'll use often when you are doing motion control. We need to get to a certain position, then we need to do some type of action. So let's go down here and let's grab the position complete bit. And we'll make that the yellow light. So that is local colon 1 colon O dot data dot 1. Okay, another good one to know is whether we are faulted or not. So we go look for our 1, and we're going to look at the linear AOI, and we want the servo fault. And we'll do an output energize for local colon 1 colon O data 2. That'll be the red light. And the final we want to do is we want to know if we need to home this, because when you first assemble your actuator, you will have to home it because the battery is in the controller and it will not know where it's at. And if we look over at YRG's explanation of everything, they actually have it built into this out 3 right here. Now, these 4 outputs are actually configurable, and we'll talk about those in later videos. But the default of output 3 is origin complete. So we're going to bring a go look for a 1 down, and we are going to go look at that linear AOI, and then we want to grab dot out, and we will go ahead and turn on the blue light with that. We can do the drag move there to get that close, and then yes, since it's just a 3 there. Okay, let's go down with this program and see what it does. And right away, we need to origin our linear actuator. And now that I think about it, that should have been a go look for 0. We should have a light on telling us that we have not homed our actuator, not a light on telling us that it is home. So let's go ahead and edit that. Let's start a rung edit. And let's just double click on the shape and hit your drop down. We want an examine off, go look for a 0 and finalize that. And now we have a blue light on. So we're going to need to home our linear actuator first thing. Now, before we can do that, we do need to turn our servo on. And remember, I left that manual. And really, I kind of think you should do that while you're learning. That way it doesn't power up and take off and do something. So let's go up to the rung that has the servo on it, and let's just right click it and toggle bit. And the moment that we do that, I can hear the servo enabled. Also have a green light now, let me know my servo's on. And if we watch our indicator as we press the blue button, it is going to start slowly going down. Also, I added this pointer on mine and a scale just so that we could talk through things on videos. And there's maybe 2 items that you should add to yours. I'll put this file and a link to the scale down in the description. So now that we are homed, we should be able to hit the green button and it go up. And it does. We should hit the yellow button and it should go down. And it does. So the jog actions are super easy. One more flaw, and I left it in there just so we could see how easy this YRG add-on instruction is to troubleshoot, is we need to switch this switch to go into auto mode. So I am going to switch the switch to auto mode because this is pretty much the same order that I feel like you're going to do it in. And then we're ready to try to move this thing. So I'm going to go down to the screen. And first, let's go look at the linear actuator add-on instruction and see what it's saying right now. Oh, it's got an error down here. And so if we mouse over and we look at the error, it says cannot execute AOI while controller is in manual mode. So let's go ahead and hit the red button. That resets it. And notice we get another error right back. And it says input per AOI parameter out of range. And I do this is not just on the this YRG actuator. I do it on kinetics. I do it on pretty much everything. PowerFlex 525 says the issue is we have no speed in this thing. So if you're going to tell it to go somewhere, you got to tell it a speed to go. So I'm going to put 50 in for the speed, and then we'll go back down and we'll reset it again. Oh, and we got another error. But notice every time we're mousing over this, we're getting the actual text of the error. You do not get this easy in any other one that I've seen. But it says servos are off, cannot execute command. And the issue is we're trying to execute the command while it's trying to reset. And that's why I left this move okay right here. I said we'd be back to it. Is we need to wait until our servos are on before we tell it it's okay to move. So let's start a run edit on that one. And we'll bring down and go look for a 1. And we're going to grab the linear AOI. And then we want the servo on. That way we know the servos are on before we tell it it's okay to execute a command. And we'll click OK. And then we'll go down here again. Now remember, you have a position command of 0 and you have a speed command of 50 when you do this. And this thing is in auto. So when you reset this, it will attempt to go there. So we will press our reset button. And it shoots down. Now we can go back into here and we can put a value of 100 in. And when we hit the enter key, it should go about a third of the way up because this is a 300 millimeter actuator. And there we go. So that takes us through setting up our generic Ethernet module and getting our AOI set up. And now we're ready to talk through some scaling and some sequencing. And I've created this playlist right here with links to both of those.